Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will talking again about sequence and series, but we already learned about introduction to number sequence and arithmetic sequence and series. But today we will talk about what is geometric sequence. Okay, in geometric sequence and series, we divide it by two, actually by three. But let's talk focus about geometric sequence. What is geometric sequence? Okay, in geometric sequence, they are divided by four. The first definition, the second general term, the third advanced general term, the fourth middle term formula. So now let's jump to the definition. Okay, definition. If a sequence Bn has the sum ratio key between its consecutive term, then it's called geometric sequence. So in here we have remarks. In other words, Bn is geometric if Bn plus 1 is equal Bn times key such that an element of natural numbers and key is element of real number. We denote them. Bn is general term of a geometric sequence and key is common ratio. Remember, in the arithmetic sequence we have monotone, but in here we just writing here, so we don't call it, we don't using part again to call it monotone, but we just to mix it. If the key more than one, so it's geometric sequence increasing when the first term b more than 0 and then decreasing when b1 is less than 0. So increasing, so that's the meaning is the member of monotone, right? And then if key more than 0 but less than 1, geometric sequence is still increasing, everyone. When b less than 0 and decreasing when b is less than 0. Remember, if the key is less than 0, then the sequence is not monotone. So now let's jump to the example. State whether the following sequence are geometric or not. If sequence geometric, find the common ratio. Okay, we already know if the geometric sequence is Bn plus 1, it's equal Bn times key. What is key? Key is common ratio. So if you want to find key, is equal Bn plus 1 over Bn, everyone. So from here, we already know if the ratio, you cannot compare them if you are not using the two fraction, right? So in here we have B1, B2, B3, and B4. And then you can compare key, it's equal B2 over B1. It's equal with B4 over, or not B4 everyone, but B3 over B2. If you want to adding B3 over B4 over B3, it's okay. But just the two of them, it's enough, everyone. So from here, B2 is 2 over 1, B3 is 4 over 2, and then B4 over B3 is 8 over 4. So it's all the value is the same, right? So this one, we can call this one is geometric, and key is 2. And how about this one? This one is the first, the second, the third, and then the fourth. So let's say key equal B2 over B1 equal B3 over B2. Okay, so B2 is 4 over 1. It's equal with 9 over 4. So 4 is not equal with 9 over 4. So in here, is not geometric. How about the last? The last is B. Okay. And then
key is equal B2 over B1. It's equal B3 over B2. Okay, B2 is minus 1 over 5, and then B3 is 1 over 5, 1 over minus. So it's equal minus 1 over 5 equal minus 1 over 5. So this one is geometric. And the ratio is minus 1 over 5. Okay, everyone? State whether the sequence with given general terms are geometric or not. If a sequence is geometric, find the common ratio. Okay, so from here, you need to remember again what's the geometric bn plus 1, it's equal bn times key. Key is common ratio. Key it's equal bn plus 1 over bn. So if we want to try to answer this A, you need to put the formula key it's equal bn plus 1 over bn. So from the question A, we just have bn. So we need to find first about bn plus 1. So equal 3 power n plus 1, everyone. So from here, we just need to substitute each them to bn plus 1, it's equal 3 power n plus 1 over bn, it's equal 3 power n. Okay, so in here, we can separate them to be 3n power 3 over 3 power n. So in here, we cancel each other. So this one is 3. Because this one is 3, so this one it's called geometric sequence with the ratio is 3, right? Understood, everyone? So how about the B? Right, we can using the same formula to find this one. Key it's equal bn plus 1 over bn. We need to find bn plus 1 first. Bn plus 1 is equal open bracket n plus 1 square plus 3. So you need to finish this one. It's equal n square plus 2n plus 1 plus 3 plus 4. So from here, we just need to substitute each other to this formula. Bn plus 1, it's equal n squared plus 2n plus 4 over bn is n squared plus 3. Okay, so from here, we can see this one, we cannot calculate them because this one is not constant. It's not constant. Constant. So this one, it's not geometry. Okay, everyone? Okay, now we enter to general term of geometric sequence. What is general term of the geometric sequence? If Bn is geometric, then we know that Bn plus 1 it's equal Bn times key such that n element of natural number and key element of real numbers. Let us write a few terms. Okay, from here we know that if we substitute n with the element of natural number, you will get Bn it's equal B1, B2 equal B1 times key, B3 it's equal B2 times key. So we can substitute B2 with B1 times key. So when we substitute this one, so B1 times key, so that's the meaning B1 times key square. How about B4? B4 it's equal B3 times key. So we have B3 it's equal with B1 times key square times key. So it's equal B1 times key power cube, right? So how about B5? B5, because we know these following rules, so we have B5, it's equal B1 times key power 4. So how about B6? So B6, the key is power 5. So from here, we get the general term of the geometric sequence is Bn equal b1 times k power n minus 1. So remember, n always element of natural number. So now let's jump to the example. If 100, 50, 25 are the first three terms of geometric sequence Bn, find the sixth term. Before we start to try to answer this question, let me to try you remember about the geometric sequence formula. So geometric sequence formula is Bn equal B1 times k power n minus 1, everyone. So from here, remember to find the what's the name? To find the ratio. So from the beginning, we already talked to Bn plus 1, it's equal Bn times k, right? So to find the ratio, it's equal Bn plus 1 over Bn. So from here, we can to find the ratio first. Okay, so to find the ratio, like I said before, you need to compare at least the two of them. Two of them of what? The second term over the first term, it should be equal the third term over the second term. So how about if you want to compare like 5 over 4, it's okay. At least they have different one terms. Okay, so from here, 50 over 100, is it equal with 25 over 50? So we cancel each other by 5 is 1 by 5 is 2. So this one half equal 25 by 25, 1 is 2. So this one is half. So we get the key is half, right? So we got the key is half, and then to find the sixth term, so B6 equal the first term times k power 6 minus 1. Okay, so 100 is the first term. So we just need to substitute all of them. B1 is 100 times k is half power 5, everyone. So from here we got 100 times 1 power 5 is 1 is over 2 power 5. So 100 it's over 2 power 5. 2 power 5 is, let me count first, 32, right? So 32. So we can divide it the both side by 4, divided by 4, divided by 4, divided by 4. So 25 over x. So the sixth term of the geometric sequence is 25 over x. Bn is a geometric sequence with the first term equal 1 over 25 and then the ratio k is 5. You need to find the fourth term. Okay, so we need to remember about the general term is Bn is equal the first term times k power n minus 1, right? So because we are looking for a B4, so B4 is equal B1 times k power 4 minus 1. So this one is equal B1 times k power 3. So from here, we just need to substitute 1 over 25 times 5 over 3, right? So from here, we can rewrite 5 over 3 over, because 25 is 5 square, we cancel the power to be, it's 5 power 3 minus 2, it's equal 5. So B4, the fourth term, I mean, is 5, everyone. Bn is a geometric sequence with the first term minus 15 and then the key or ratio 1 over 5. Find the general term. We know that geometric sequence have general term. It's Bn equal the first term times k power n minus 1. So we already have the first term, we already have the the ratio. So we just need to substitute all of them. So minus 15 times ratio is 1 over 5 power n minus 1. So from here, we can make it simplified to be 1 over 5 power n times 1 over 5 power minus 1, right? So we want to change the form about 1 over 5. 1 over 5 is 5 power minus 1 times minus 1 from the exponents. So from here, we can rewrite minus 15 times 1 over 5 power n minus power 1, 5 power minus 1 times minus 1, it's equal 5. So this one, it's equal minus 75 times 1 over 5 power, yes, correct, power n. Consider the geometric sequence Bn with the first term equal 1 over 9 and the ratio is 3 is 243 a term of this sequence, 243 I mean. So we know that general term of the geometric sequence is Bn equal the first term time k power n minus 1. So we have everything in here, so we just need to substitute. So we don't know 243 what's the term, so let's say they just is general term b to n. So 243 it's equal, the first term is 1 over 9 times, because the ratio is 3, so 3 power n minus 1, everyone. So from here, we can continue to be, so 2 for 3, it's equal 1 over 9 is the same what with the 3 power 2, right? Times 3 power n minus 1. So we need to simplify this one to be 2 for 3, it's equal 3 power minus 2 times 3 power n minus 1. So from here, we know that 2 for 3, it's 3 power 5. Is it true? Yes. 3 times 3 times 3 times 3 times 3. 993. 81 times 3 is 243, everyone. So from here, we can change 243 to be 3 power 5 is equal 3 power n minus 1 minus 2. Okay, so we cancel 3 and then 5 equal 9 minus 1 minus 2. So 5 plus 3 is equal n. So n it's equal x. So it's true. 243 through 243 with bx. Okay, everyone. So I hope you understand what I'm explaining today. A geometric sequence with the first term as 1 over 3 and then the ratio is 1 over 3 is given. The ninth term of the sequence is, we remember that general term of geometric sequence is Bn equal the first term times k power n minus 1. So from here, we have B5 or the fifth term, it's equal 1 over 3. And then we have ratio 1 over 3. So they ask about 9 terms. They ask about 9 terms. If we substitute from here, so 9 terms times the first term equal the first term times k power 9 minus 1. So the 9th term it's equal b1 times k power x. So we need to find the first term, everyone. So we can find the first term using the fifth term. The fifth term is equal the first term times k power 5 minus 1. We have the fifth term is 1 over 3. It's equal b1 times k power 4, right? So from here, we can change to be 3 power minus 1. It's equal b1. 1 over 3 power 4. So we need to change the form to be 3 power minus 1 power 4, right? So from here, we need to find B1. B1 is 3 power minus 1 over 3 minus 4. So B1 is equal 3 power minus 1 plus 4. So this one is equal 3 power 3. So we have B1 is 3 power 3. So we need to substitute to here. B1 is 3 power 3 times. The key is 1 over 3 power 8. So we can calculate to be 3 power 3 over 3 power x. So this one is meaning 3 power 3 minus 8. So this one is equal 3 power minus 5 or equal 1 over 3 power 5 or 1 over 243, everyone. So that's explaining from me. In a monotone geometric sequence, the first term times the fifth term is equal 12, and then the second term over the fourth term is equal 3. You need to find the second terms. So from here, we know that monotone from the definition, if k more than 0, that's the meaning increasing. Increasing is the member of monotone. So k more than 0, is that the meaning k positive, and then you can using the 2. So this one is the meaning k positive 2. So from here, we can using from B2 over B4. B2 over B4, it's equal B1 times k power 2 minus 1 over B1 times k power 4 minus 1. We can cancel the first term each other. So this one it's equal k power 1 over k power 3. So from here, we can write 1 over k square equal 3, right? Okay. Why this one? We cancel the power to be 2. So from here, we want to that to be k square, it's equal 1 over 3. So k is plus minus square root of 1 of 3. So this one is k positive and minus 1 over square root of 3. Because they're talking about monotone positive, so we just take the q positive. Q positive is that the meaning q it's equal 1 over square root of 3. So from here, we have the key, and then we just need to substitute to be. To be what? To be B2. How can it be? We can using this one. Okay. We can using B1 times B5 equal, B1 is still B1, right? Times B5 is B1 times k power 4. And we have the value of B1 times B5, it's equal 12, equal B1 times B1 is B1 square times k power 4, right? So from here, we got the k is 1 over, or we can write 3 is 3 power minus half power 4. It's equal 12 equal the first term square times 3 power minus 2. So 12 over 3 power minus 2 equal B1 square. So from here, 12 times 3 power 2, it's B1 square. Okay, so we got the B. From here, we get the B. Yes, correct. So square root of 12 times 3 power 2 equal B1. So we got B1, it's equal 12 is 2 times 3 of square 3, right? So this one is 6 over 3, everyone. So we have 6 over 3 because they're talking about the second term. The second term is the first term times k power 2 minus 1. The first term, I mean 6 power 6 root of 3 times key power 1, 6 square root of 3 times 1 over square root of 3, we cancel each other. So we get the second term is 6, everyone. Bn is a geometric sequence with the fourth term is 56, and then with the key minus half, find B9, right? So from here, from general term, we can using general term is Bn equal the first term times key power n minus 1. So we have before, but we don't have the first term. So we can using the fourth term to find the first term times key power 4 minus 1. Okay, the fourth term is 56 equal the first term time key power 3. Key power 3, so 56 equal the first term times key is minus half power 3. Minus half power 3 is correct. Minus 1 over, yes, minus x. So we need to find the B1, the first term. So 56 times minus x is equal the first term. Okay, let me count first. 56 times 8, 4, 44. Okay, so we got that minus 440x for the first term. Okay, and then we can continue to find the ninth term. The ninth term is equal the first term times the key power n minus 1. Because we're talking about the ninth term, so B1 is minus 440x times key minus half power 8. Okay, so from here we can minus 440x over 2 power x, 2. Okay, 4, 4, 4, 4, 16, 16. So 16 times 16, 256. Okay, minus 448 over 256. Okay, we can simplify this one to be minus 7 over 4. So you will maybe, oh, why this one so hard? No, we have advanced formula. So you don't to be worried to find the first term first. But after this, I will explain to answer this question with the advanced formula. Okay, now we will continue to the advanced general term formula of geometric sequence. So now, okay, advanced general term formula. From this example, the previous one, we can find the required term without finding the first term if we know the p term and the ratio to express Bn. Okay, we know that general term Bn is equal the first term times key power n minus 1. But I want to change the n to be p. It's just symbol, everyone. Just symbol. But the root still element of the natural member. So the p term is equal the first term times key power p minus 1. So making a side-by-side division of the 1 by 2, we will get this one. But if you're curious, let's ask to prove. Okay, we have Bn over B key. So we can cancel the B1 over B1, right? So we just to make simplify between the power because they have the same value or the same not same value but the same variable. So this one is key power n minus 1 because the denominator wants to be changed to numerator, the power change the sign. So this one p because from here positive minus and then plus. So we got the Bn over B key is equal k power n minus p. So make it simplify again. So we get the formula Bn equal Bk times k power n minus p. But in here, they have a rules. If the power of the p is less than n, okay, or we can say n is greater than p. So now let's jump to the example from the previous one. Bn is geometric sequence with before the fourth term, I mean 56, and the key is equal minus half. You need to find the 9 terms. But we already learned about the advance of general term formula. So from here, we got the formula is Bn is equal Bp times k power n minus p. So this one, they have a rule, everyone. What is the rule? The rule is p less than n, or we can say n is greater than p. So from here, because they're asking about the 9 term, so we can write the 9 term. So, but we have the 4th term, we can change the 4 terms times k power 9 minus 4. So we have b 9 term, it's equal b4 times k power 5. Okay. And then from here, we can substitute that we have b4 is 56 times minus 1 over 2 power 5. Okay. 56 is 8 times 7 times minus 1 over 2 power 5. 2, 8 is 2, 5, right? 2 power 3 times 7 minus power 2 power 5. We cancel 3 and 5 to be 2. So this one is equal minus 7 for 4. So everyone, if you just have the term beside the first term, you can using the advance of general term. Bn is geometric sequence with the fifth term is 1 over 332, and then the eighth term equal 4 power minus 4. Find the common ratio. So we just have B5 is equal 1 over 32 and B8 equal 4 power minus 4. So for easier to answer this question, you can using advance of general term. Advanced general term is Bn equal B times k power n minus p. So from here, you need to remember what's the rules. The rule is p more less than the n, right? So we can take the B8 equal B5 because they're talking common ratio times k power 8 minus 5. B8 is 4 power minus 4 and B5 is 1 over 32. Right? 1 over 32 times k power 3. So from here, we know that if the 4 is 2 power 2 times minus 4, it's equal 32 is 1 over 2 power 5 times k power 3. So we can finish this one to be 2 power minus x. It's equal 2 power minus 5. It's equal k power 3. So this one, 2 power minus x over 2 power minus 5. It's equal k power 3. So this one, 2 power minus x plus 5 equal k power 3. So 2 power minus 3, it's equal k power 3. So we can conclusion this one to be, to be what? To be correct. So this one, let me finish this one first. K is the square root of 3 from 1 over 2 power 3. So the key is square root of 1, 3
or square root of 3 to power 3. We can cancel this one to be the 1, and then this one we can cancel. So this one is k equal 1 over 2. So we get the ratio with the help of the advance of general terms. Okay, everyone, now we will the last of the geometric sequence, middle term formula. Middle term formula or geometric mean, you already learned about mean in your junior high school. Okay, in a geometric sequence, BP square is equal BP minus K times BP plus K, where K more than P. Okay, so we want to prove, is it true our formula or not? So dividing BP equal BP minus K times K power P minus K. If you confused about this one, you can check again about your general term. And BP plus K equal BP times K power P plus K minus P will give us, okay, because we are talking about dividing, we dividing each other. So from here we can cancel each other with the K, and P minus P plus K is the same with this, in the right and in the left side is the same. So we get the formula BP square equal BP minus K times BP plus K. So from here, let's jump to the example. Given an geometric sequence Bn with 6 terms, it's equal 8, and you need to find the third terms times 9 terms, because we're talking in the middle term. Middle term is, we know that BP square it's equal BP minus K times BP plus K, where K less than P. Okay, now we just have 6. Okay, and then we have 9 and we have 3. Okay, imagine that if I took that 6, because we just have the 6th term, I took 6. If the 6 plus 3, it's equal 9. If the 6 minus 3, it's equal 3. So we know that if the P is 6, yeah, and then the K, it's at 3, right? So we just do using this formula, B 6 square is equal B 3 times B 9. B 6 square is 8 powers 2 times. And then this will be result is 64 equal B3 times B9. Okay, everyone? I hope you understand about this. 1 minus x, 6x, and 19 minus 2x are 3 consecutive terms of geometric sequence. So from here, we know that the first term is 1 minus x, the second term is 6x, and the third term is 19 minus 2x. And then they told us you need to find x, everyone. So from here, we can using the middle term formula to find the x. Remember, b p square is equal b p minus k times b p plus k. Okay, so from here, we have the 2. If we adding 2 plus 1, it will be equal 3. So we can conclude this one. If the 2 minus 1, it's equal 1. So this include this one. So from here, we know that k it's 1 and the p it's 2, everyone. So we can using this formula. So b2 square, it's equal b1 times b3. So b2 square is 6x power 2 equal b1 is 1 minus x times 19 minus 2x. So we need to simplify this to be 36x squared equal 19 minus 21x plus 2x squared. So let the one side equal be 0. So this one is equal 34x squared plus 21x minus 19 equals 0. So from here we can write to 17x 2x equal, because they are 19, so we put this one minus 19, this one we put wait, 17, 19 minus 1. So this one we can put plus 1. So 19, 2, 8, 3, 1, sorry, 3, 30x minus plus 17, 1, 2 minus. Oh, so this one is wrong place. This one, it should be plus. Okay, and then this way, it should be plus. So, oh, sorry, this one, it should be minus. So 17, 38 minus 17, 21. Okay, so we got here. Okay, so we got the value of x. 17x equal minus 19, or 2x equal 1. So x equal minus 19 over 17, or x equal 1 over 2, everyone. So from here, we get the x minus 17 over minus 19 over 17, or x equal 1/2. Find the common ratio key for the geometric sequence. The first term is 32, and then the second term times the ninth term is 2. So we need to find the key, so we can using the second term times the ninth terms. The second term is, the formula is b1 times key 2 minus 1 times the first term times key power 9 minus 1. So b2 times the b9 it's equal 2, and then we have the same b1, so b squared, the first b squared times key power 1 plus 8. So 2 equal b1 2 key power 9, right? So from here, 32, it's equal to power 5. 2 equal 2 power 5 square times 2, key power 9. So from here, we get 2 over 2 power 10 equal key power 9. So we can cancel here, and then here it's to be 9. So 1 over 2, 9 equal key 9. So this one is key equals square root of 9, 1 over 2 power 9. So this one is equal 1 over 2. So we get the key is half. Three numbers from a geometric sequence. If we increase the second number by 2, we get arithmetic sequence. After this, if we increase the third number by 9, we get a geometric sequence again. Find the three initial number. Okay, everyone. They give us three number from a geometric sequence. So we know that the geometric sequence symbol is B1, the second term, and then the third term, everyone, right? This one is geometric sequence. Geometric sequence. Geometric sequence is B key square. If you curious where I get this one from Bn, it's equal B1 times key n minus 1. Okay, but B1, it's the same with the B, so I don't want to put the 1 in here. Okay, this one is called by geometric sequence. If we increase the second number by 2, we get an arithmetic sequence. So from here, if the second term, the plus with the 2, this one is to be arithmetic sequence. After this, if we increase the third number by 9, b key plus 2, b key square plus 9 to be
geometric sequence again. They told us find the three initial number. Okay, remember, to find the geometric sequence, the first thing first, you need to do with the ratio. Common ratio. Common ratio is Bn plus 1 over Bn. But like I said before, remember, to find the ratio, you need to compare the both of them. Okay? You need to compare the both of them. So in here, we just have the three terms. So we can compare to be key, it's equal B2 over B1. It's equal B3 over B2. At least they have different one. Okay, everyone? So we using the third because the third is geometric sequence. So B2 is B key plus 2 over B1 is B. It's equal with B key square plus 9 over B key plus 2. Okay, we need to simplify this one first. So this one is equal B square key square plus 9B. It's equal B square key square plus 4B key plus 4. This is I just times each other by numerator and denominator. So from here, we can cancel each other between B square, K square in the left and the right side. So we get the here 9B minus 4, it's equal 4B key, right? So from here, we can continue to be 9B minus 4 over B, it's equal B key. Or you want to make it simpler again, it's okay, 9B minus 4 over 4, it's equal key. Sorry, this one is B. Okay, everyone. So you get the ratio from the third equation. So now we want to find the difference from the arithmetic sequence, which is arithmetic sequence, it's come from the second equation, right? Already get the ratio from the third equation, right? So from here, I want to find the difference. The difference we are using from the second. The second is this one. We have this one from the second. So difference, we know that the difference is the formula, the second term minus the first term. You need to put the equal with the third term minus the second term. We have that the second term is B key plus 2. B key plus 2 minus B, it's equal. The third term is from B key square. B key square minus, you need to open bracket to make little bit wrong, right? To make it the percentage of your wrong is little. And then this one is B key plus 2. And then we just need to solve this one. Okay. B key plus 2 minus B, it's equal with B key square minus B key minus 2. Okay, from here, we need to collect each other. Okay, let me put the B key in the left side and then the rest of them to be the right. B key plus B key minus B key square, it's equal with minus B, I put in the right side, B. Plus B, I put in the right side, minus 2, and then minus 2. So we have 2B key minus B key square, it's equal with B minus 4. So from here, you can grouping them by key. So let me erase. Let me put the B key. 2 minus key, right? B square, 2 minus 2B square, it's equal with B minus 4. So from here, we can substitute the key that we have from the geometric sequence to arithmetic sequence, and then the B key too. So B key is, this one is B key, 9B, minus 4 over 4. This one, it's equal B key. You can use the key, it's equal with 9B minus 4 over 4B. So from here, we can continue to B. Substitute this one. Okay, 9b minus 4 over 4, close bracket with the 2 minus key. What's the key? Key is 9b minus 4 over 4b, close bracket. It's equal with, yes, b minus 4, everyone. So from here, 9b minus 4 over 4, you can make this 2 with the same denominator to be 4b. So this one is 8b minus 9b plus 4. Okay, this one b minus 4. So from here, we get that 9b, oh sorry, let me erase this one. 9b minus 4 over 4, open bracket, minus b plus 4 over 4b. b minus 4. So from here, you need to simplify of them to be get, wait, let me write this one. To get the 4 times 4b, we can put in the right side. So to be this one, 16b, open b minus 4. So from here, 9b, they just left 9b minus 4 times minus b plus 4, everyone. So you just need minus 9b squared plus 36b plus 4b minus 16. This one is equal with 16b squared minus 64b. Okay, so let me simplify this one first. 14b minus 16, it's equal with 16b squared minus 16 4b. Okay, so we continue to this to get the simplify. Let me put the 0 in the left side. So 0, it's equal with 16b squared plus 9b squared minus 64b minus 40b plus 16. Okay, so 0, it's equal with 25b squared minus 104b plus 16. So from here, you need to make, yes, factorize. So from here, you can make the factorize with 25b with b. 16 is 4. 4. This one is minus and then minus. So we get the b. We get 25b minus 4, it's equal 0, or b minus 4 equals 0. So you get 25b is equal 4, b equal 4 over 25, and then b equal 4. So you get the b, right? You have to b. So you need to substitute this one to get the key. What's the key? Key formula is, we know that the key formula 9b minus 4 over 4b. 9b minus 4 over 4b. So we can make it simplify this one to be 9 over 4 minus 4 over, no, minus 4, but minus 1 minus 1 over b. Okay, just substitute the first b. I want to substitute b equal 4 over 25. So the key is 9 over 5 over 4, minus 25 over 4. See, the key is equal, it's equal with the minus 16 over 4. It's equal minus 4. So we have the first key, minus 4. And then substitute the b, it's equal with 4. So key, it's equal 9 over 4 minus 1 over b. Okay? So from here, 9 over 4 minus 1 over 4, it's equal with 8 over 4, it's equal to. So we have the 2 of the key. So we can substitute the both of them to get the value that we want. Okay, everyone. Now we will continue to find the terms. Okay. When we substitute b equal 425,
we get the key, it's minus 4. And then we know that the first three terms is geometric sequence, so that the meaning B key square is geometric sequence, right? So we just need to substitute what we have. B is 4 over 25 for the first term. This one is the first term. And then B times key, it's equal with 4 over 25 times the key minus 4. So we have minus 16 over 25, which is this one is the second term. And then we need to find the third term is B times key square. It's equal with 4 over 25 times minus 4 square. It's equal with 64 over 25, which is this one is the third term. So we have the B and the key for this, and then we want to try to find the B, it's equal 4. We get the key, it's equal 2, right? Okay, we just substitute what do we have? B key square, it's equal with, B is 4. This is the first term of the geometric sequence. And then we have B key. B key is 4 times 2. It's equal this 8. And then B key square. It's equal with 4 times 2 power 2. It's equal 16. So from here, this one, 16 is the third term. 8 is the second term. So this one is 4, 8, 16. Okay, everyone? I hope you understand what I'm explaining. So if you're curious or you don't understand what I'm explaining, please let me know in my YouTube comment below, okay? Thank you. Three different number with an arithmetic sequence with different tree. Okay, we have three different number. So we know that difference from arithmetic sequence is the first, the A1, A2, and then A3, right? And then they have difference tree. Just put difference tree. We should remember about the general term of the arithmetic sequence is the first term plus n minus 1 times d. Okay, so from here, remember, A1, you can write with the A plus n minus 1 times d, everyone. So from here, from the third terms, we change to be A plus D, A plus 2D. Because the third minus 1 is 2, right? And then we change them with the difference. They have difference 3, so A plus 3, comma, A plus 6, because 2 times 6. Okay, from here is done until this question. Now we continue. If we decrease the second number by 1, that the meaning decrease is less than. You get minus with the second term, our second number, and then A plus 6 is staying there. We get geometric sequence. We get geometric sequence with the sum of element as 14. So this one, sum of the third of them is 14, everyone. So they told us the ratio of the geometric sequence is, okay, remember, ratio it's equal with the B2 over B1, it's equal with B3 over B2. Like I said before, you need to make it equal. Okay? So from here, the B2 is A plus 2 because 3 minus 1. The B1 is A. And then the B3 is A plus 6 over B2, A plus 2, right? So you need to times by with each other. So the result will be A square plus 4A plus 4 equal with A square plus 6A. We can cancel each other, A square with the A square, and then 6A minus 4A. 4 it's equal with the 2A, and then we get the A, it's equal to. So A, it's 2, right? So we want to know what's the ratio they have. So we just need to substitute the ratio from the geometric sequence of this. So, okay, we have the A is equal to, so we need to substitute this equation from geometric sequence. A plus 2, A plus 6, so A is 2, 4, and then the 8. So we need to find the ratio. Ratio is equal B3 over B2 or equal with B2 over B1. So B3 is 8, B2 is 4, it's equal with B2 is 4 over 2. So this one is equal to, it's equal to, right? So we have the ratio is 2, everyone. So I hope you understand. Three numbers from an arithmetic sequence. So we know that arithmetic sequence is the first term, the second term, and then the third terms, right? We know that arithmetic sequence, they always have difference D, right? So we can rewrite again with the A1 plus D, A1 plus 2D. Okay, from here, this one is called arithmetic sequence. And then we continue to write this question. If we increase the third number by 2, third number by 2, okay, everyone, if you don't want to write the 1, it's okay. You just need to A, it's okay. It doesn't matter. And then decrease the second number by 2. The second number by 2, then we get a geometric sequence. So A, then we get this one geometric sequence. If we increase the third number by 2, so from here, A plus 2D plus 2, it's equal to 4 times the first number. It's equal with the 4 times the first number, everyone. So from here, we have this one. We can using this one to get the difference. So 2D is equal with 4A minus 2, everyone. So 2D is equal with 3A minus 2. D it's equal with half 3A minus 2, okay? So from we can say this one first and then we can say the second. So now we will continue to find the geometric sequence about ratio. Ratio from geometric sequence is B2 over B1. It's equal with B3 over B2, everyone. So from here, we can continue to B2 is A plus D minus 2 over A equal with B3 is A plus 2D plus 2 over B2 is A plus D minus 2, everyone. So from here, we can times by with them. A plus D minus 2 square, it's equal with A plus 2D plus 2, right? So from here, everyone, we know that A plus 2D plus 2, it's equal with the 4A. So we can cancel, we can substitute them and then we have the D, of course, substitute them too. So A plus half 3A minus 2 square equal with A times 4A. And then we simplify this one to be A3 over 2A minus 1 minus 2 square. It's equal with 4A square. And then A plus 3 over 2 is 5 over 2A minus 3 square equal with the 4A square, everyone. So from here, finish this one first. So it's equal with 25 over 4A square minus 5 over 2A plus 9 equal with 4A square. Okay, we can cancel this one to be 3. So 25 over 4A square minus 15A minus 4A square plus 9 equals 0, right? Because we want to find the A. And then the both side times by with 4. So this one is equal 25 square minus 60A and then minus 16A square plus 36 equals 0.
So this one it's equal with 9a square, right? Yes, 9a square minus 60a plus 36. We need to factorize of them to be 9a, 36 is 6 with 6, minus 9 times 6 is 54, 54 minus 6. Okay, so we have the a, 9a is equals 0, 9a minus 6 equals 0, or a minus 6 equals 0, right? So we have 9a equals 6 over 9. Oh, no, 9. I mean like this one. A equals 6 over 9 or 2 over 3. And then A equal 6, right? So you already find the first number of arithmetic sequence. If you want to find what's the arithmetic sequence, the sequences, you can continue that. But that's enough to find the A 2 over 3 and then the A equals 6, everyone. Find for number forming a geometric sequence such that the second term is 35 less than the first term and then the third term is 560 more than fourth term. Okay, everyone. So from here we have the geometric sequence. Geometric sequence is B1, B2, B3, and B4. From here we have the Bn equal B1 times k power n minus 1, or the simple say bk power n minus 1. So from here they give us the second terms, it's equal with the 35 less than the first term. So that's the meaning B1 less than 35. And then the third terms is equal B4 plus 560. So from here, B2, we know that B2 is BK equal B minus 35. Okay, so from here, we need to find the B. So B minus BK, B1 minus K. So 35 over 1 minus K is B. So from here, we have B3 is equal BK square equal B4 is the BK power 3 plus 560. So from here, we can substitute the B. But before we substitute, let me write like this one. BK square minus BK power 3 plus equal 560. So BK square minus K power 3, it's equal with 560. So B is 35 over 1 minus K, open bracket with the K square minus K3 equal with 560. So we need to simplify this one to be 35 K square minus K power 3 equal 560 times by with 1 minus K. So you need to finish this one first. 35 K square minus 35 K power 3 equal with 560 minus 560 K. So make the other side or make one side to be equal 0. I want to put in the left side. Oh, okay, I will continue the new page. The left side equal with 35 K power 3 minus 35 K square minus 560 K and then plus 560. So from here, we divided the both sides with the 35. So the simpler is K power 3 minus K square minus 16K plus 16. So from here, you need to factorize by the power by 3. So the K is plus 4, K minus 4, and then the K plus 1, everyone. Oh, no, plus 1. Sorry, K minus 1, everyone. So from here we get the ratio. The key is equal minus 4, or the key equal 4, or the key is equal 1. What's the question they ask? Find first number forming a geometric sequence. Okay, find the first number. So we have they give us find the fourth number forming geometric sequence. So we have the B key, B key square, and then B key power 3, right? So from here, you can substitute all of them to find the fourth value. Okay, I think that's enough for me to find the key, so you can continue to find what's the term from this one. Okay, everyone? Okay, everyone, we already learned about the geometric sequence, the four of them. Now we got to exercise. In exercise, please do exercise in Check Yourself 9, page 45, and then Check Yourself 10, page 49. Okay, everyone, thank you for today. So see you on the next meeting about geometric series. So thank you. Assalamualaikum warahmatullahi wabarakatuh.